Hello everybody and welcome to day 25. I'm a few minutes late, so I will start right away. Now, as usual, photofreak.com. If you want to get the code in text form, go on GitHub. You can reach it from here. In the repositories you will find didactic, and all the days are going to be there. They're split by seasons. And that's pretty much the meat of it for the scripting episodes. And the website, and normally I have comments in the posts whenever a video is released. That's also so that there's something that's text-based available for people to, well, for the search engines to respond to, and that's about it. Now, where we got to the last time was we had figured out how to get the leg global component working, and we tried swapping the plugs and it was good. So, well, in this case removing the plugs. What we got to with the script instead was the ability, let me have a look. So this is the equivalent of our main, where we basically test things. We got something where from the tool panel we could retrieve the plugs that we care about, so we can find the origin plug, the guided plug. We store plugs in it with the unplug copy trick to make sure that they're less volatile than they would normally be. They're for immediate consumption, we don't need to hang on to those. So that is about it. And this dictionary is gonna be per plug. So what I would like to do today is actually get it to do something. And I think we're on the right track to get that done. So, a couple of things. Now, the config parameters, we figured out that if we hook these, let's actually also, okay, maybe I wanted less than that, but that's still fine. We figured out that if we plugged directly into the matrix modes, and I would expect these to be contributed to a couple of those, there you go. Because of the nature of the arrays here, so if we, instead of going through the config parameters, we will go directly from the guide to there and then remove the guide, which is our plan. When we have two parameters that have no origin, it basically means swap the plug for nothing or remove the connection. The array will basically compress the physical indices, so we would end up with an ID matrix in there, which meant that we had to store it somewhere so that this connection remains live. We're okay with that, but what that means is that these config parameters, and this sort of makes sense anyway, is basically a property of the control and not a property of the guide. We need it to stay. If we delete the guide after that, we'll incur in the same issue. So I'm moving it to the control so that when we delete the guide, we're gonna be fine. Now, because there's nothing in there, having moved the config, I could probably, and we'll try, I could probably delete the guide like that, which is one of the qualities of doing things this way. And we are basically now good to go. Like, the rig works, you know, we don't need to do any swapping, which in a way is a little bit unfortunate, I guess, but as in it's not as good a case as I was hoping to show. We'll do for some other component, we'll show a more pertinent case, but yeah. So for the global, it will be that easy. Just deleting the guide will be good. I suspect that for part of the leg, it will be the same. We're still going to do this work. Now, the last thing before we start in earnest is, it will make sense here, where we are saving the origin and guided, to expand this dictionary a bit and store the connection, so plug X, okay, and store the original connection that that plug had. Now, I said that in here, to toggle the guiding on and off, we can just store the origin plug, store the current the current source of the plug that we're monitoring, and and be good to go. Okay. And be good to go, because at that point guided and origin will keep swapping, and we can toggle between guide and not. So ankle global offset, let me have a quick looky at these. So right now there's nothing because we want to swap to nothing. We want to look at where that is connected, and if there's an origin here, that will be something in control. We swap this one in for the origin, and we take the one that was in origin and connect it there, and if we do the same thing again, we basically swap between control and guide. So with that in mind, it makes sense to also store the current source and set it to none. So we do have a 2 swap plug. We are finding the sub plug, copy sub plug. Okay. So from there, sorry, I've started on the scripting basically now. So from there, what we want to do is, for guided, find the plug that is being guided, find the source of that, and get it. So subplug can children count. Where am I doing that? To swap plug, I'm configuring it here. Element count. Also couples, okay, that's good. Element plot to swap element logical index I, and then I go over the children, subplug dictionary. So what I'm doing there, okay, still makes sense. What I'm doing there is basically iterating here, and based on that name, popping things into that. which will leave me with these empty. Now, if guided is connected, and it should be, we would expect it to be. So if subplug dix guided is not none, then we want to find the origin of guided. And so that will get us a plug. So we can check his source, which is actually a property. So in this case, we want to store the current source as well. We might as well give it a name, even if it's a transient one. Does chat, I'm trusting you as usual. Does what I said make sense? Like, is it clear what we're doing here? What we're aiming to do at least. So if guided plug is not none, and if it is a source, then we basically want to store its source. Now every plug can only have one source, so you can have many outputs from one. So when you get the connections that are outgoing, you can get, well, you will get an mplug array even if there's just one connection. When you get the source, you always get a singular one. So, and I believe it's a method. Let's check that. So yeah, source is a method, and it will tell you what plug is sourcing it. So current source is gonna be that. And we are still gonna use the copy trick to make sure that it's non-volatile. We're probably being overly cautious here, but it beats crashing. We're only dealing with a small amount of plugs, so even in final code, I will probably be this cautious. It's unlikely that there will be like hundreds of these to swap around, even in a very, very large component. So our poor man debugging, we're gonna print that. And I think you can do include object name like that, just to get something. So swapping plugs, what are we calling these? Let me see. It's swapping plugs, so I had already copied this file. That's good, go me. We should be able to simply reload these and run it. That's my expectation. Yes. So anything selected in the leg global will do as at this point. It's not printing anything, and that current source is none, so let's have a look. Make sure that... Oh no, it was coming in. So... well, we will get one each. So if guided plug is not none, and guided plug is source. Oh, we want this destination. That makes sense. We are looking at this plug here, so we want to make sure it has a source. So we need to check if it's is destination is an invalid keyword argument. Okay, fine. I don't. It's maybe include node name or something like that. Let's not bother with it. So encode global offset, we're printing the subplug dix partial name. What am I doing here? I am stupid. Definitely not what I would want. I want to set, yeah, I would have made a mess of things there. And encode global offset. I do have something selected, so no attribute partial name. None type. So what am I'm doing something stupid here. There's no doubt about it. I am. So guided plug is getting me these. That's not, nobody typed anything. Do I need to get the source twice? Probably not. Yeah, probably yes, and what I've been missing. So I don't know why I was doing this. So this is correct. It should. Guided plugs of is destination. That seems correct to me. So it's so that's poor man debugging. This will be easier with the debugger attached, but I don't want to get into setting up debuggers and all of that. And so easy the destination. True and false. So true for one, false for the other. Oh, I need to do that inside. That's it. Foreign range element count. Fijian range children child count. Yeah, somebody was saying that's what I do most of the time for debugging. It's fine when you're starting. When you start having a larger amount of work that you need to work with, it's a lot more convenient to attach a debugger. But like there's a you know, solid 1 or 2 hours of lessons, I guess, just to show how to set it up and how to use it, and it makes things a little bit less approachable. So for now I'm doing the simplest possible thing that might be familiar to most. So guided plug is destination. I would have expected both of them to say yes. So this will be the children count of the sub plug. Sorry, this is bothering me. I will obviously find that it's a shameful moment and it was obvious. So guided, none. Then I'm current source. Yeah. Current source. So it is, that is interesting. Now, print all swap couples. Don't need these for now. Because well, do I have? Yes. So it's definitely not none, but it's saying that it's not a destination for one of the two, which makes me wonder if I am storing the right plug. Guide plug, oops. And then guide plug is not defined. Guided plug, of course, it's not defined. To swap and to swap, guided and guided. True and false. It's okay. This is officially doing my head in a little bit because it is connected. So I got 0 and 2. Now, is there an empty one or something like that? There shouldn't be, and it doesn't matter all that much anyway. So that's the difference I was talking about between logical and physical index. 0 and 2, so that's a physical index. And that's getting us through. Okay, so the logical index is actually having something in there that's orphaned that I cannot access anymore. That is annoying. Anyway, all right, for now we'll use the physical index, which is the one that should be responding to the compression. It's getting us the right IDs and all of that. I'll have to figure that out at some other point in more detail. Now, so I wasn't doing anything wrong other than using the logical index. So, threw me off my groove for a moment. Let me catch up to what I was doing. So that's a guided, that gets us the source. And that is what we want. So that should get us. Origin guided is cool. So we're storing guided. We might as well pack more information here. So this is the guided in here. We want to save these and these both, I reckon. Well, we do care for these because it's... Well, no, we don't care for these actually because we don't want to reconnect anything in there. We know that we want to always work with that plug. Okay, this is a little bit more... the slightest bit more involved than I thought it would have been, but I think we got it now. So we do have the guided plug in here. we do want, I guess, the guided source. And we do want the guided source will be that. So as we're doing that job, sure. And I can't believe I'm stumped for names. Probably should have called these guides, I don't know, guidable, whatever, it doesn't matter. Because this is convenient for us, so I'll keep it that way. Guided source and guided source, like I don't like that. Anyway. See, this is doing my head in a little bit. We don't really care all that much to store this one. Sorry for that, I need to drink for sure. I'm trying to think if we ever need the guided here, and we really don't. So we'll keep these names. Then what we do is we are fetching it, then we're gonna replace it. It's a little bit not super nice, I guess. So we might as well split things instead of doing. That was kind of nice though. So partial name R split is going to we're splitting for the dot to get to the right side of the compound. That's okay. Then what we're gonna be doing is if plug key equals origin, then we definitely just do that. Else plug key equals guided. Then I want the source of that subplug. I don't want to store these. I don't want to have multiple, like the whole chain when I don't really need this. This is our ground truth. This stays connected. The origin is the one that we want to do the swap job on. So if it's guided, then it makes sense, I guess, the guided is this plug here. And for origin, we might want to track the source actually. We will definitely want to. I'm making a mess of these, and I shouldn't really, because this is pretty trivial. So let's keep what we have. Let's start with that, and let's get ourselves a new loop where we track the relevant plugs. Sorry, this is messy, but it's gonna stay. I'm gonna still have it in the video because it's probably gonna be important. So this is gonna be what we have for the tool panel, which means that the one that we want to rename, I guess, is not really the plugs or what we're doing with them. It's the swap couples. So that becomes the tool panel couples. And that's okay. Then what we want to do is work off that. So we want to build a new dictionary. So two panel couples is fine. And then we want the actual plug couples. which should be the same thing. Hopefully that makes sense. So I was chasing my tail on something that I shouldn't have been on, where I was going like, oh, the interesting plug is actually this, and the interesting plug for the origin will actually be what the origin is connected to. I still want to track these. I was about to expand this dictionary, but it doesn't seem wise. What we're really interested in is this plug, the one that origin is connected to, which might be none, and the source of the guided plug. And we're gonna separate that. So we can still for now keep it in here and do so this is the subplugs dictionary, origin and guided. We're already sizing this by the element count, so we are then gonna do, okay, so in here we're fetching all the guide tool plugs first. Oh, come on. Then what we do is I could copy this dictionary without deep copying it. But meh. So origin and guided is actually still valid as a name, which might be confusing. We'll have to be careful, but not auto-completing. Active. So active plug couples. I equals, we want an active plugs dictionary. And we are gonna keep the same name. Hopefully it will be useful rather than confusing, because we won't be using these much. Maybe we will later on, but it doesn't matter all that much. Some of the text is, oh, thank you. And I hope the text is readable and it's not too small. In fact, I should probably move these to PyCharm. There you go. And I do have the spare page. So if guided plug is not none, what am I doing here? Okay, this is the part I want to recycle. Two panels, subplug deep. So it always sounds funny when you say subplugs deep. Sounds like something else. Anyway, juvenile. So now we're gonna be working on the actual sources. Banshee clear doesn't like plugs. You calling my daughter Banshee? That is rude, man. You haven't heard her at her best. This is nothing. Now working the actual source plugs to the track ones. We are gonna keep these. Hopefully not behind. I need to reinstate the green screen. It's just a little bit painful lighting wise. Now these for now we can comment out. Don't need yet. Then in this case we can now have a guided source and we can make sense of it. So what we want to do is, I don't want to do some key iteration thingy. I am happy doing an extended case. So I want to do, if this one, what's it called, origin is not none, then I will do something. Otherwise I can leave it none. I want to do the same for guided. Then if guided is none, we're in serious trouble because it means we don't have a series. So I might want to let that error, but not just now. Then this should at this point have become an actual plug, and if it is a destination, then I want to do something with active plug couples. Come on. Nope. I am stupid. Okay, I can do this. So, okay. This is just to know that I need to do something with those. I reckon we're getting closer. So, if origin is not none, then we want to get the source, and that should be a singular plug. And what we want to do is an mplug copy of the one that is inside the... Oh, is this called subplugs dict? Not super fond of that. So refactor that. Really did not like it. Then we want to go truck plugs dictionary, possibly origin. No, doesn't seem like a good idea. So the active plugs dictionary origin is gonna be the source of the truck plugs dictionary. Oof. Source and no to completion for me. Yeah, I really need to sort that out. I thought I had, but not in these not in this project. Better. We're getting somewhere. So, and this might be none, and that would be okay. Now, if guided is none, then we have a problem. So, let's actually do... Let's put a sofa to do in there for now. So active plugs guided, copy the source of the track plugs dictionary. Now, if so, we should never, like, if we error here, we should never encounter a case where this is not, like, this should always be true. That's the simple matter of fact. If active plugs dict guided is not none, if we want to keep the same, but this should error brutally before then, so I'm okay with these erroring here. So, oh. Now that should have a source. So if we're tracking that plug, we're finally here. It's possible that it wouldn't have a source. So it's not a ideal case. It's not the case you should encounter most of the time. It's very possible that it might not have one. I mean, yeah, it's so visible. I hope this is still making sense to you guys. It became a little bit more developy and scripted and, you know, teachable. Well, I guess these are teachable moments. But I was hoping it to be more of a lesson-y kind of thing. It's become a, I need to deal with this crap. But it should be okay. So, this is the active plugs dictionary, and guided should exist at this point. And I want to get the source, and I would expect it to exist. So, I want to do the OM2 and plug and copy thingy there without a doubt. What is possible, and okay, this is actually probably a lesson-y moment. Source will return you a null plug, which is not a bad thing for the record. Now, and it should be in the notes, I believe. So it will tell you if it is source with conversion. Okay, this is if you use, if you have unit attributes in unit conversion nodes in between. If it is a destination, it returns the source plug. If it is not a destination, a null plug is returned. So it always returns the same type, which is good. And this is a thing that matters a lot in the C++ API, and this is a pretty good reflection of the C++ API, so it's still the case. Which means we don't get a none if this is not connected. We always get a plug. Now, if that plug, the guided one, was connected to nothing, the end plug that we get is going to be a null plug, so you have to test it for that. So let's do that. Finally, we're getting there. The copy should still retain the nullness of it. I don't want to do a double copy. Oh, sorry, I would not want to do a double copy, but I'm gonna do it for safety. Now, if guided plug source is null, and is these, let me see, because these I don't remember if it's a property. No, this is, yeah, this is a property, not a method. So if it's null, then we do nothing. Actually, even better, if it's not null, then we can store this result in the dictionary, which is gonna be the active plugs dictionary guided source. I'll need to remove that space, equals that. If not, we leave it to none. Do we still need these? I suspect that we don't. Sorry. We don't need these anymore. And we do want to do the poor man debug operation of printing. I reckon that will get us somewhere. Now, what I want to test with that is also that we handle that none case. So let's select something in the global. Error expected indentum block. Why? Guided plug source. I will admit to being puzzled by these. So you are showing me an error, and PyCharm was not. Oh, yes, it is showing me an error, but like PyCharm is showing me the error sooner and less, obviously. So let's reload so that I can keep... Yes, reload, please. Okay, guided sewers. So we're doing okay here, I feel. Now, let's also do... so k.v name for kv inactive plugs it dot iter item invalid syntax. I thought this was valid syntax. I thought... Good run, guys. Hey, see you, Jordy. No, whatever. Let's I'll have to... I don't have the time for that. It's the dictionary comprehension might be key only, which will make sense. Built-in method. Okay, sorry, for plugs it's a method. So I got origin, guided like global config parameters, ankle global offset, so that's good, and the word matrix, that is good. Now the other thing I wanted to test is these. Attribute error, none type as no attribute name. That is very good, because what it means is that it's found that it's null. So I would expect that to print. Sorry. What time is it? Okay. Yeah, I found no plug. And that is exactly what I would have expected and hoped. Because if you operate on a null plug, all bets are off. You can get in very real trouble. So, no, I don't need to save that. Let's see. Yep. Okay, next thing we want to do in here is do the actual swap. Oh, sorry. I got 10 minutes and I was hoping to get to do the full swap today. I might not. But I like to make some I like to go part way towards it. I also need to factor these out and clean it up a little bit. But the swap itself we're gonna do with OM2. So here's the thing. I'm really torn. Before I do the swap, I wanted to do a mini theory lesson. Alright, let's go for, well, not so much theory, but some suggestions. Shield your eyes. It's going to be very bright for a second, because Mischief opens in pure white. Free Santan. I have to look at whether there's a way to actually change that so that my default is reasonable non-suntanning color. So, speaking of development now, we have a few possible cases here where we don't really care about the track plugs at this point. Active plugs dictionary, where is it? The track plugs, they were just means to an end, which was getting the actual active plugs. So now that we have those, we do care for a bunch of situations. So origin guided should never be none. The guided source could actually be none, and it will be non-fatal, because what that will mean is simply that this is a guided plug, but it just doesn't have a source. And we were talking about, for this guide to work in toggle state without deleting the guide itself, we will be swapping for an empty origin. So our unguided state, if you want, while the guide is still usable, will be that. with this not having an effect. So that is a pretty valid state. And what I'm doing here is listing possibilities, and it's something that I do recommend you do yourself when you're in a situation like this, which is getting the expansion of all the possibilities. So, and try them manually first if you can. If it is something that you can do trivially like it is in this case. The origin being non-connected is also possible. That's what we have now. So is the origin having something connected to it. So what do we have? As far as possibilities go, I probably don't need mischief with this, but I wouldn't mind doing it like that. You have, I can do this, you have a possibility matrix. And that means that you have, you need to, okay, I can do this. I believe in my ability to draw, actually, no. Whatever, fine. So here we say that we have origin, guided, and guided source. That is our data. And let's call this just source. Now, we are saying that it's possible for this to be none or to actually contain a plug. So, and again, I will normally have, well, I wouldn't do it for something this trivial maybe, but I will normally have a notebook at hand when I do this kind of work, and I would actually do this. And it will be easier with pen and paper. So these are possibilities. Now, if you were to do this, this means that you basically have 6 possibilities. And it's not a bad idea when you're prototyping code, and I guess we're gonna get this note done and close it on that. It is not a bad idea to do something like if, where is it? This is gonna be verbose, but that's okay. Sorry for that. I need to prop up the keyboard when I do this. Sorry, if this is none, pass, else it's gonna be a plug, pass, and then you do it twice. So this gives you 6 things to implement, and it's tempting when you're in front of something like this to go like, oh, you know, if this is none and the other one is none, that should happen and so on. And it's okay if you have a very clear idea of what the cases are gonna be. Let's separate these maybe. Then you can start thinking in terms of like multiple and nested ifs and so on. But if you're exploring something, even if it's gonna get you boilerplate, it is not a bad idea to figure out all of your possibilities. You know, do something like that, annotate yourself, implement all of them, and then compress after that. Because the boilerplate, it's not gonna take you hundreds of lines for each of these. The boilerplate is gonna tell you what compress is. Otherwise, the other thing you can do is, and these are basically our cases, you know, what are we testing against? None is plugged, so we're doing these. And then you can go something like, look, guided, none, this should never happen. I want red, please. This should never happen. So if you implement it as an error, or you go like, I've taken care of it sooner than that, so yeah, I'm not gonna do that. Now, guided, sorry, source being none or being plug, very possible. So you need to deal with it. But they are subs of free. So what you end up with is that origin might be none or plug, and that's true. Then you end up with guided having, you know, only the possibility of plug, and that being source, none, or plug. And this is pretty much an assumption. So all you need to implement at this point, if you can always assume these to be one case, it compresses away. All you need to implement is these cases. So when origin is none and when origin is none and the source is none, what do? You basically do nothing. So you have 0, 4. Do nothing. When origin is a plug, anyway, you get the idea. Sorry, I don't want to start. I was looking at the time. I don't want to start doing everything expanded like that. But hopefully these make sense to you. So you have these 4 possible states, and they might lead you to n amount of combinations of dealing with them. Chart them out. It's not a bad exercise. Chart them out in code by typing them explicitly, or do it on paper. But yeah, these are mutually exclusive, so you cannot have 0 and 1 happening at the same time. So what you could have to deal with is origin does have a plug and source does have a plug. These exist. You cannot have horizontals in these. So in this case, where the source and the plug both exist, then what you want to do is swap the plugs. Now these two cannot exist at the same time. If there's a source but there's no origin, oops. And hopefully you get the idea, you get what I'm saying here. What do you do then? And that's, then that gives you basically the amount of cases that you have to implement. So 0 and 5, there's going to be no origin, but there is a source. Then you will want to disconnect. Now, once you've done that, you know that these become your real cases. Chat, is this making sense? And it might be like it is super obvious. It's just the notion that occasionally, instead of like writing right away, or writing in this immediate mode where you look at the next bit of the problem, stop for a second and think of the way the code could branch. So instead of doing these, and I'm curious as well, how many people do something like that? Is it a new thing to you? Like, have you ever thought of working that way? So we have swap, do nothing, and disconnect. Now, swap is going to be, we said, for 1. So we got source is none. No, sorry. I have done this the wrong way, have I? I have. So I'm leading you astray. No, sorry. 0 and 4. None and none. Do nothing. Let's get them in the same order. Otherwise, I'm going to connect my... I'm going to confuse myself to all hell. So do nothing is going to be 0 and 4. And it's going to be origin none, source is none. So do nothing, you can express it this way. And this is how you go towards branchless code. This is a lot more common in functional programming than it is in the classic, like very sequential, very imperative programming that you normally do early on as you're learning. But I think the basic notions are pretty easy to get for anybody. So do nothing is the consequence of my track plugs origin being none. Track plugs dictionary origin is none and source being none. So instead of checking things, here I am expressing what the expectation is, and I say source. What did I call it before? Guided source. could have probably just called it source. And I should use active plugs. I will get it right one day. I'm glad I noticed on time. This would have been insidious. Now, disconnect instead, we said, is going to be, let's make sure that it's right, 0 and 5. So it's going to be origin is none and source is a plug. Origin is none and we say this is do nothing is double none and this is not none. And the last one we care about is the swap, and that will be that both are a plug. So there's see, there you go, there's what am I doing here? 4 and 1, I said source none and plug 1. So this is incorrect to begin with. Let's actually, that's why I was confusing myself first. This is a swap. Now if the source is none, let me look at it in Maya because it's kind of hard to juggle these and talking. So there's nothing here. Oops. But there is an origin. Whoa. So we have an origin and we have nothing here. So we want to connect. And that's it. That's cool. So it's basically, tempted to say that it's a swap to nothing. So we could compress it in here. But we might also want to track. So this is, yeah, it gets a little bit tricky, but it's basically a connect case. Okay, I can make sense of it. Where we're taking the original plug that we're supposed to reconnect, source has nothing in it, and we are good to go. And as you can see, and this is what I was saying, when you do something like that, if we had more possibilities, you will see that guided by being a no choice basically disappears. There's guy that kind of gets us these, but it's really not that important at the end of the day, because what we care about the most is what to do. I mean, it will be receiving the effects of these, but all of these, the fact that guided is a no case, they all need the guided plug as a target. And that's it. Actually, target is a different thing in Maya, so let's call it. What am I doing here? And we say swap is gonna be 1 and 5. So origin and source are both none, are both plug. We are saying neither of them is none. And it'd be better to use affirmative statements if possible. So you could go, you know, is instance and plug or something like that. But for now, we're trying to not complicate things. And the last one will be, what did we say? Swap is like that. So see, there's some compression that we could do as well in here. But I don't want to do it, because if the source is none, it's like connect and swap for the most part remain the same, but it gets a little bit tricky. It might be connect one, disconnect the other. It doesn't really matter. We're not, you know, we're not going to implement exactly like these anyway. But let's use the same annotation. So connect equals source is none and plug is not none. And I might be making a royal mess of these, as in the text might be reversed or something. Source is none, and what am I saying here? Connect is for 1, so source is none, plug is... Ah, I can do this. So source is none, and active plug origin is not none. So what we should have is 2 not none. Yes. If you look at the pattern here, hopefully you can read these. Okay. Yeah, seems to be mostly there. I should get the extra page in. If you look at this pattern, for something that has 4 cases, I will never actually space code like this, but this is going to be useful. Then what you have is none and none, none and not none, not none and not none, not none and none. So this is 4 combinations that you would totally expect. The pattern makes sense as well. Now, based on these, we can now take action. And we might, you know, we might compress further where you go, oh, look, if it's a... there's 2 kind of actions, which is reconnecting the origin to some new attribute for the swap. That happens in these 2 cases where the guided thing is a connection that is different than the one that's in origin. So we also have a use for comparing these and the potential origin. Like, it gets a little bit more complex than that. But anyway, oh, I'm way over. So I'm gonna call it here unless there are questions. Nobody piled any in. Food for thought. We are gonna, let me go back to here. We might not implement like these. We might implement like these. We'll figure it out tomorrow. There's no hurry. But if you want, you know, if you're following at home and you're doing more or less what I'm doing, I will put the scene up for download so that you have exactly what I have and you don't have to go through these stuff. I should probably have done it a couple of days ago. And then try and fix these by yourself if you want homework. It will be useful. Try extending the cases before you compress them. Try and figure out if there's a different matrix of possibilities that you care about. Because it doesn't, like, I'm working off the raw data here, so this is a very obvious option. But you also have another matrix of possibility where you go, okay, you know, it's the matrix of equality where you go, let's take away guided. We still say it's a known case. And this is really going to be the last of it. So origin and origin are always going to be equal, obviously, but are origin and source the same? Actually, let's do it. So is origin the same as source? What is it? Origin, guided, and source. Yeah, I should have done it like that. Anyway, so is origin the same as guided? Is origin the same as source? Is, you know, guided the same as source? Is guided the same of origin? You can see that compressing right away. I should have spared myself this one because I don't know what I was thinking doing it as a diagonal, because that only has one outcome. But anyway, that's another matrix of possibilities that you might be interested in, and you might choose to go and use a subset of these, of what value those plugs are, and intersect it with whether origin and source are the same or not, and so on and on. So the last 2 or 3 minutes, probably a bit rambly, but hopefully you get the idea. Definitely in the food for thought category, but do it at home. I'm giving it like a minute scarce if you guys have any questions. Otherwise, I'm gonna call it here because I got a dash to work. and the stream is catching up now. All right, there don't seem to be any questions about this. I have not modified the Maya scene, don't need to do anything there, and PyCharm saves all the time. All right, I'm calling it. Thanks everybody for watching. If you're watching these on YouTube, the time references are meaningless to you, might be years from now. If you are watching the stream, thank you for attending, and I will see you tomorrow, possibly, where we finally actually finish these, hopefully.